Welcome back to the Deep Dive. Today, we're taking a trip not just into memory, but into the very architecture of consciousness.
Right.
We're asking, can small, wild backyard birds actually engage in mental time travel?
Mental time travel. It sounds like something out of a sci-fi movie, you know?
It really does.
But it's actually a cognitive ability we humans use every single day. It's called episodic memory. It's that subjective feeling of reliving a unique past experience, putting yourself right back in that moment.
And that's the thing. We can't exactly sit down with a blue tit and ask it about its day or its feelings.
Right, you can't.
So researchers have to look for behavioral proof. They need an animal proxy for that really complex human ability.
Exactly. In non-human animals, we look for what's called episodic-like memory, or ELM.
ELM, okay.
And to demonstrate ELM, an animal has to prove it can recall and integrate 3 distinct components of a single past event. The what?
Yeah.
So what happened? The where, the location, and the when.
The when being the time that's passed since it happened.
Pers-
And this is the critical distinction, isn't it? It's not just semantic memory.
Right.
It's not just knowing a fact like sunflower seeds are high-calorie food.
No, it's remembering I got that high-calorie sunflower seed at Feeder B maybe 3 hours ago, and, well, they're probably gone by now. It's a personal story.
And for decades, research into ELM has been almost totally dominated by food-hoarding birds.
Oh, absolutely. The classic subjects, like western scrub jays, they bury thousands of caches of food.
Wow.
So they have to remember the specific contents, the exact location, and how much time has passed to know if, say, a nut has spoiled.
Yeah.
It just makes perfect evolutionary sense for them.
Okay, so the study we're diving into today, the Davies et al., one from 2024, this is so significant because it just ignores the specialists.
Completely.
It focuses on the generalists. We're talking about wild, free-living, non-caching species.
The blue tit and the great tit.
Yeah.
I mean, these are common garden birds, generalist foragers. They're not specialized memory champions.
And the research took place entirely in their natural habitat.
Which is huge. The fact they use this sophisticated technology out in the wild is what makes it so powerful. They essentially turned the field into a high-tech laboratory.
Okay, so let's unpack the mission here. The researchers, they weren't satisfied with just one measure. They used 2 distinct complementary tests for ELM.
Right, 2 paradigms.
First, the content test. That's the standard what, where, when, or WWW memory test. And second, a process test, the incidental encoding, or IE test. Let's start with the big one, the WWW content recall.
Well, the methodology is just brilliant because it's so personalized. Every single bird that participated was fitted with a tiny PIT tag.
A passive integrative transponder.
Yeah, think of it like their personal ID badge or a microchip. So when a bird landed on one of the automated feeders, the feeder instantly recognized that specific bird and its personal history for the day.
So they could tailor the whole foraging experience for hundreds of individual birds at the same time, all out in the wild. That's a massive technological step forward.
It really is. And the scenario they simulated was a very realistic food source that depletes over time. They set up feeders with 2 food types.
Okay.
Highly desirable sunflower seeds, and then less preferred peanuts. And crucially, the contents were always hidden from view until the bird actually committed and landed.
Now, the temporal rule, the when part. That's always the hardest piece of the puzzle, isn't it?
Yeah.
How did they create a personalized time constraint that wasn't just tied to sunrise or some fixed time?
They engineered what you can think of as a personal 2-hour window.
A personal window.
So when a specific bird, let's call it bird A, landed on the preferred sunflower seed feeder for the first time that day, its own individual 2-hour depletion period clock started ticking.
And during those 2 hours, the good food was available.
Exactly. It was like their own personal happy hour.
And this is so key. It didn't matter if that bird arrived at 8 a.m. or 1 p.m.
No, the clock started based on their arrival, not the sun's position. But once that 2-hour window was up, the replenish period began. And for bird A, the door to that preferred feeder slammed shut until the next day.
But the peanut feeder, the less preferred one.
That one remained open the whole time. A reliable backup.
So if the birds were using ELM, they had to be tracking 3 pieces of information to make a smart choice.
Right.
What food was best, where it was located, and when they last visited to know if their personal 2-hour ticket was up.
And that is exactly what their behavior showed. It was amazing. The birds showed this highly significant relative change in preference.
How so?
Their first choices for the less preferred peanuts were significantly higher after long intervals.
So after their 2 hours were up.
Yes, during that replenish period when they knew the preferred seeds were unavailable. This was compared to the short intervals, when they knew the good seeds were still accessible.
So that switch in behavior is the evidence.
It is.
If the clock had expired, they stopped wasting time and energy checking the good feeder and went straight for the reliable, the secondary source.
It's cognitive optimization. Why spend metabolic energy and time repeatedly checking a feeder you know is depleted?
Then you can just get a guaranteed, if slightly less exciting, reward.
Exactly. The successful choice wasn't just finding food. It was efficiently deciding not to even search for the high-value item because memory told them it was a complete waste of time. They integrated the what, the where, and their own personal when.
That's really compelling evidence. But as we know, science demands more.
Always.
The researchers knew if they just stopped there, critics would immediately claim the birds were using some simpler, non-episodic cognitive shortcut.
Of course.
So they had to systematically destroy all the simpler explanations.
And that's the critical phase, right? Ruling out those confounding variables. For instance, could they just be making familiarity judgments?
Right, choosing the feeder that felt less familiar because they hadn't seen the food yet.
But they controlled for that. All the feeders were presented at the same time, and the food was obscured. So the feeders shared the same relative familiarity until a choice was made.
What about using the environment? I mean, with wild animals, the easiest shortcut is usually the sun or the daily cycle.
They completely eliminated the circadian rhythm or any daylight cues. As we said, that 2-hour window was totally individualized.
Based on the bird's own arrival.
Yeah, and by randomizing that window's start time between 8 a.m. and noon every day, they made external fixed-time cues totally irrelevant for predicting when food was available. It forces the bird to rely purely on its internal autobiographical memory of its own visit.
Okay, and what about the most common defense from skeptics? That the birds were just using simple trial and error.
The win-stay-lose-shift strategy.
Yeah. I went to the good feeder, it was closed, so now I'll shift to the other one.
They accounted for that brilliantly. They only analyzed the bird's first choice after the time interval had passed.
Only the first choice.
So if a bird chose the preferred feeder during that replenish period and found it closed, that was recorded as a failure of memory. They didn't analyze the next visit. The measurement had to be based on the initial recollection, not just a reaction to immediate failure.
That is extremely tight methodology. What about social cues?
They thought of that too, social information. Because the timing was unique to each bird, one bird's preferred food might be available while its flockmates was already depleted.
So one bird failing gives no reliable info for another bird.
Exactly. It precludes the use of shared social information.
Okay, that makes the WWW test really robust. But let's move on to that second complementary test, because this is where we get into the process of memory.
Yes.
Why wasn't the what, where, when test enough on its own?
Because the WWW test focuses on content recall. It's about recalling pieces of information you might have deliberately chosen to remember because they were relevant to getting food.
But for ELM to truly mirror human episodic memory,
It'd have to involve automatic encoding.
Okay, so we need to test if the birds are automatically encoding details that were, at the time, completely irrelevant to their main goal.
Exactly. Like, if your main goal is to sign a contract, remembering the color of the chair you sat in, that's the incidental detail. It proves your memory process automatically captures background information.
So this is the incidental encoding test.
The IE test. They ran 2 versions, a where test for spatial info and a which test for visual info.
Let's do the where test first. The main goal was food, but the incidental information was the physical layout of the feeders.
Right. They were set up in either a specific triangle array or a linear array. So during the encoding phase, the birds visited a single feeder with highly visible food. The spatial array, the triangle or line, was just background noise.
Irrelevant.
Totally. Then about an hour later, in the memory phase, the feeders were reset in the same array. But this time the food was hidden and they couldn't access it. They were forced to use memory.
And what did they choose?
They performed significantly above chance. The birds preferentially visited the feeder in the same spatial position as the one that held food earlier.
So they recalled the incidental spatial location of their previous meal, even though that location was totally unnecessary for their goal when they were first eating.
Yes. It demonstrated automatic spatial encoding for both blue tits and gray tits.
Okay, now for the which test. This one focused on incidental visual memory details like colors and patterns.
Right. For this test, the feeders had distinctive visual characteristics, like a yellow dot or a red stripe. And to make sure the birds couldn't just fall back on spatial memory,
They mixed it up.
they intentionally swapped the spatial layout. So if they encoded the info in a linear array, they were then tested in a triangle array. They had to choose based purely on that incidental visual cue.
And this leads us to what I think is the most surprising finding in the whole paper, a genuine age anomaly. It just complicates the story in the best possible way.
It's utterly fascinating. They found a significant effect of age in this specific visual test. Juvenile birds, so the younger tits, performed significantly above chance levels.
So the young ones remembered the color or pattern.
They did. They successfully encoded and recalled that incidental visual information.
But the experienced adults...
The adult birds did not perform above chance.
Wow.
They just didn't appear to retain that incidental color or pattern information as effectively as the younger birds. For visual cues, the juveniles are the cognitive high flyers.
So, to recap, we have two strong converging lines of evidence for ELM in wild tits. They passed the WWW test for content recall, and they passed the IE test for automatically encoding spatial location.
Right.
But when it came to incidental visual encoding, there was this major cognitive split based on age.
Which is a major finding. It suggests that this sophisticated ELM capability, the ability to flexibly remember what, where, and when, and to automatically encode background details, is far more widespread among common species than we ever thought.
But let's zoom out. What's the adaptive benefit here? For these generalist foragers, why evolve this complex memory process? They aren't hiding thousands of caches.
Because their world, while it's not centered on caching, it's defined by patchy dynamic resources. They need flexibility.
Okay.
Think about a concentrated insect bloom on one specific tree. It appears at a certain place at a certain time, and then it depletes quickly. Or garden feeders that empty and then replenish hours later.
I see.
ELM allows for rapid, flexible decision-making without having to rely on the slow process of building habits through weeks of reinforcement learning. They can grab information on the fly and apply it strategically.
And testing them in the wild confirms that this is a cognitive ability they're actually using.
Absolutely. The study highlights that lab studies can sometimes give you weird or inconsistent results because the captive environment just doesn't reflect the evolutionary pressures.
Right.
If you restrict a bird's world, you restrict its behavior. By testing them in their natural woodland habitat with real competition and dynamic resources, we confirm that this memory system is vital for their everyday survival.
Okay, let's circle back to that peculiar age anomaly. The adult-juvenile split on incidental visual memory. It raises such a fascinating question about how experience shapes memory. Why would experience reduce performance in one aspect of memory?
It's likely tied directly to their life stage and, their ecological needs.
Yeah.
We know that juvenile blue tits and great tits are often better at innovating new foraging solutions.
Why is that?
Well, perhaps because they're often outcompeted by the more dominant adults at familiar, reliable food sites.
So the juveniles have to be more flexible. They have to grab every single piece of information they can get.
Exactly.
If the color of a feeder is the only new cue that points to a new food source, they'd better remember it.
Precisely. They might be cognitively primed to use any and all incidental cues. Spatial, visual, social, whatever, helps them find new food and avoid competition. The successful, dominant adults, on the other hand, may have learned over time that the most reliable information in their environment is stable spatial location.
You mean the adults might suppress their reliance on visual cues like color, which can change frequently, because they've learned to prioritize stable spatial cues.
It's not that they can't remember the color necessarily, but that they've evolved a strategy to filter out information that, over a lifetime, proves less predictive of long-term success.
It suggests that memory isn't just a fixed capacity, it's a dynamic, adaptive strategy.
It is. The successful adult may have specialized its cognition to focus on the information most vital to its established territory, while the juvenile remains this broad-spectrum cognitive innovator.
So this deep dive really shows that being well-informed isn't just about reading a memo. It's about efficiently recalling the content, the context, and the timing of a past event, a skill that keeps these common garden birds fed and thriving.
These wild tits give us one of the clearest examples yet that episodic-like memory isn't some monolithic trait found only in specialized species. It's a flexible toolkit adapted to the demands of a dynamic environment. And the thing that really sticks with me is that difference between the juvenile success and the adult reliance on stable cues. It suggests cognitive specialization continues to evolve even after maturity. The next time you see a great tit visiting your garden, Just remember that you're looking at a highly flexible cognitive strategist, adjusting its memory system based on its stage of life, that flexibility itself. That might be the ultimate survival tool.